This video will explain the strategy called Reductio strategy. So the pattern of reasoning in the dash in and dash out proofs is traditionally called Reductio ad absurdum, which means reduce to an absurdity, or reduce to something that's obviously false. So the strategy that goes along with the dash in and dash out proofs will be called the Reductio strategy. And the Reductio strategy says, use when you don't see a way to get your goal directly. Assume the opposite of your goal and try to derive a standard form contradiction. Once you get the standard form contradiction, then you can derive your goal by either dash in or dash out, as the case may be. Let's see how this works in an example. So suppose we have the argument P arrow S, B and D arrow not S, not T arrow B, and D and not T as the premises. And then suppose our conclusion is not P. Well, we don't see any way to get not P directly, so we need to try to get it indirectly. So we're going to use the Reductio strategy. So we'll start out by assuming the opposite of our goal. So we'll assume P, and that's a provisional assumption. So that means we need an assumption dependence column now. So lines 1, 2, 3, and 4 are all assumptions, so they all depend on themselves, as does line 5, because that's a provisional assumption. Okay. Well, P will let us get S from line 1, from lines 1 and 5, by the rule of arrow out, and that will depend on 1 and 5. And then I'm going to take not T out of line 4 by ampersand out, and that'll depend on 4. And I'll use that to get B out of line 3, so 3 and 7, arrow out. So that will depend on 3 and 4. Then line 9 will be D by 4 ampersand out, and that will depend on 4. And then I can make B and D by 8, 9 ampersand in, and that will depend on 3 and 4. And then that will give me not S by 2, 10, arrow out. So that depends on 2, 3, and 4. And then line 12 will be S and not S. So we've gotten our standard form contradiction. And that's 6, 11, ampersand in. And that will depend on what line 6 and line 11 depend on. So that's 1, 2, 3, 4, 5. There we go. Okay, and line 13 then will be our goal. We can get not P. And since we started with an unnegated formula and we're adding a negation when we finish our derivation, we will use the rule of dash in. And that will be lines 5 through 12. And so that will depend on everything that the SFC line depends on, so everything that line 12 depends on, which is 1, 2, 3, 4, and 5, except for the provisional assumption that is the opposite of what we're deriving on this line. So except for line 5. So it will depend on 1, 2, 3, and 4. And those are all assumptions, so we haven't broken the big rule.